Well, hello and welcome to our second video on the convergence of generative AI, spatial technology and augmented reality. Now in this video we're going to stay focused specifically on generative AI, and we're going to try to demystify the technology in this one. So this series is aimed at folks that are relatively new to augmented reality, so to artificial intelligence, generative AI. So I wanted to do a really high level view on the technology and how particularly technologies like ChatGPT actually do their learning. So that being said, let's dive in. So as I mentioned in the first video of the series, this is really aimed at folks that are relatively new to generative AI and machine learning and AI more broadly. So in this second video in the series, we're going to dive a little bit more into the technology, but keep it at a reasonably high level. So I'm going to try and use analogies as much as I can to help explain some of these concepts. So let's jump in. Let's do a very quick review. So if you haven't seen the first video, I encourage you to go back. There's some reference points in this video that talk about some of the things we covered there, but more broadly, we're really talking about the artificial intelligence world. Now within that is machine learning. So that's sort of the big discipline is artificial intelligence. Machine learning is really machines learning from data. And that's, again, we spoke about that, what that actually means, and we'll again cover some of those points in this one. Deep learning is where we dive into neural networks, and that's very relevant to the world of generative AI. Deep learning being these really big models, these really big neural networks. So that's kind of what that stands for. And then a really important point to remember as we walk through this is really more broadly in the deep learning world, we have these three pieces. We've got the input, which is the data. We've got the model, which are the algorithms, the functions which process and do the work against that input. And then we have the output. So really important concepts, and again, keep that in your mind as we walk through this stuff, and we'll do quite a lot of we'll dive into models quite a bit here in terms of generative AI. This slide's got too much writing on it, I apologize for it, but I wanted, before we jump into generative AI, just to talk about this notion of intelligence. So, you know, a lot of people worry that AI is this intelligence thing, that we're eventually humans will be replaced. If you think about humans, we really take our cognitive abilities for reasoning, problem solving, learning, all those things that are on the slide here, but a lot of that is around sort of the biological pieces, the relationship pieces. So there's a very complex web of what makes up intelligence for humans. It's simpler for AI. AI is really algorithms and data processing. So it's looking for patterns and analysis, etc., etc. So even though that word intelligence is used against AI, it really lacks the nuanced understanding and adaptability, as I've said there, that we've got in human cognition. Will it ever get there? Lots of debate about that. Very unlikely is my perspective on that. Okay, so let's dive into generative AI. As I mentioned in the last video, it's a branch of AI focused on creating new content such as images, video, text, and music. Now this is the exciting piece of this. We can actually start creating, or actually the exciting and what makes most people nervous, that we can actually now go from zero to a song, from zero to something written for college. So this creative part of generative AI is really what's got people excited and worried. But that's basically the definition of generative AI. So who are the main players? Well, there are a lot of players in the market and ever more, but if we sort of go back in time a little bit, well, actually in the top right hand corner there, Google DeepMind actually goes back to 2010. So it was a Kiwi and a Brit who set that up, and it was bought by Google in, I think I'm looking at my paper, it's about 2014 is when Google bought DeepMind. So DeepMind is important. OpenAI, obviously we all know about OpenAI. 2015 is OpenAI. Runway is an interesting one that we'll talk about. They date back to about 2018. Meta, can't ignore the fact that Meta are involved. And then Hugging Face dates back to, I'm looking at 2016 so 2016 is when Hugging Face came out. So there's just a few of the big players in the marketplace. This is rapidly expanding. The money these guys are spending is off the charts on this stuff, because this is not a cheap enterprise to actually build what we're talking about here. So these guys with deep pockets have been first in, and they've been the most evolved. Their solutions are the most evolved. But again, there are others now coming into the market. There's others building on top of these guys. So it's a very dynamic marketplace. And again, I'll make the point, it's relatively new. So, Gen AI model categories. So let's just walk through, again, remember we've got the input, we've got the model, we've got the output. We're talking neural networks here, we're talking deep learning because they're really big. So what are these different models that sit in this middle space when it comes to generative AI? Language models are what we hear about a lot about, and LLMs, large language models. We're going to cover that in a lot more depth in a future slide, but that's one group. We've got these image generation models, and diffusion models is one type of image generation model that's out there. So we can actually start creating images essentially, and we can do image manipulation, etc. within that world. So creating new content, which is image-based content, is diffusion models, and I'll actually talk a little bit about how those work in a bit. GANs are another form, quite complex, but another form that's really focused on imagery. There's some video in there, but GANs are another group of models. Then there's video, and this is relatively new. This is evolving right now. VAEs are an example of this. And then we've got into music generation models and code generation models as well. So there's a whole load of generative AI models that are out there, are being built and developed and trained, etc. So those are the main categories. So let's just look at those, just look what falls under each of those groups. So you've got under sort of the language models, GPT-4, GPT-3, which is from OpenAI. We got Gemini from Google. We got Llama from Meta. So those are the language models, important language models. These are the image video ones. DALL-E 3 is OpenAI. We'll talk a little bit more about that. There's Gen 2 from Runway. I just mentioned Runway, and then Stable Diffusion X is another example. And then from a code perspective, that is generating code for folks. You hear a lot about, Python is particularly popular in the world of generative AI and AI more broadly. And we'll cover in a future video, we'll cover Python. But there's a couple of really notable code generation models, which Code Llama is one from Meta, and then StarCoder from Hugging Face is another one. So just a few examples of where each of these some of the groupings, some of these projects that are being developed within each of these categories. Now, you're going to hear a lot about multimodal this year. Now, multimodal, I don't know whether you can actually read that, but it says, I asked ChatGPT-4, don't create an abstract image, create a very simple image which could be used to explain GenAI multimodal, and it's come up with that image. Basically multimodal, and it's interesting, we'll talk about this again, that ChatGPT, which is an LLM, text to text, is generating imagery. But that's an image in ChatGPT-4. It's a pretty complicated image. It isn't really the image I wanted, but multimodal basically means these are models which can work with multiple different inputs and outputs. So it's not just text to text, it's text to image, it's video, it's music, but it's a single source where you can actually go and you can actually work with all of these things. A lot of these projects are sort of separated. They're, it's just text or it's just imagery, but we'll get to a place, I think, this year where we'll start being more multimodal. And ChatGPT-4, I should say, is already multimodal. Okay, this is another little bit of a wordy slide, which I apologize for. But how does Gen AI learn? So it basically takes huge data sets. It sort of analyzes those data sets, identifies pattern structures and relationships within that data. So that's the guts of how Gen AI works. So its training enables them to generate new content that resembles the training data. And again, I'm going to do another slide in a minute, which really dives much more deeply into how this works. And we're actually going to kind of use LLMs as our example in that case. So its learning is often unsupervised or semi-supervised, and there's this term backpropagation. We'll explain that in a minute. But at a high level, think about the fact that these models are trained on massive data sets, and they get to learn off of those data sets in a semi-supervised or unsupervised way, actually. Some of the nuances, some of the structures, some of the elements of this that allows them then to create new data. So high level, that's kind of how it all works, and we'll dive a bit more deeply into actually the structure of this and how they do self-learning. So we spoke about LMs. We're now going to dive into large language models, which is that one particular group, and arguably the most popular at the minute of these large language models. So what are they? Well, they're text-focused chatbots. If you've used ChatGPT 3 or ChatGPT 4, it's basically a chatbot. You type in a question, you type in something, and it'll come out with text. So it'll go through its process, and it'll come out with something. So it's essentially a sort of intelligent chatbot. Yes, it's based on these large neural networks, and yes, it's trained on these huge data sets. In the case of ChatGPT, it's the whole of the internet basically, which is, obviously absolutely enormous. This is a really important point that I'm going to cover in a minute. What it does is predictive text generation. What do we mean by predictive? And we'll talk about that. From that process, it actually starts to learn context, and that's how you can actually feel as though you're having a conversation with ChatGPT like it's human, because it's actually understanding the context of what you're typing in. Now there are a wide group of there's a wide range of applications. I mean, translation's one. We can actually build all sorts of different things using ChatGPT and these LLMs. And we'll talk in another video about some very specific examples of how this is being used and could be used. And I'll actually give you an example of some of the areas that I use these LLMs to help me. So I'll walk you through a really good example of that. And it's got continual learning and limitations. If you look at ChatGPT 3, that was against a data set from, I think, 2022. ChatGPT 4, which is a different animal, is much more updated. I think it's March 2023 when ChatGPT 4 is trained to. So they're only as good as the data they're trained against is the point. They're not continually learning on an ongoing basis. They're only as good as what is their training data. Okay, LLMs and learning. So LLMs use the transformer model. That's the fundamental model they use. It doesn't have to be the transformer, but that seems to be the most popular model that most of these LLMs are now using. Now, I mentioned training data. In the last video, we spoke about training data. Now, that's structured and unstructured data. So structured means it's labeled, unstructured means it's not labeled. So it's usually a mix of structured and unstructured data. And if you think across the web, again, using ChatGPT as an example, it's using data that's of both of those types off of the web. Now, I've highlighted this particular bullet point because this is going to be covered in a minute, and this is critical. And frankly, when I first came across LLMs, it took me a little while to get my head wrapped around this. But GPT stands for Generative Pre-trained Transformer. There's that word transformer. So it's referencing that model, and it's pre-trained. So we'll talk about that in much more depth in a sec. And the way that LLMs work is they're actually done in it's a supervised learning approach which guesses the next word. So again, bear with me, we'll talk about what that actually means, but that's how they're trained. They train to guess the next word. Now, fine-tuning is the next level. With these pre-trained models, you can actually take them to another level. So fine-tuning means, and it's a complex process, fine-tuning, but it's task-specific and highly accurate. So if you want to take a pre-trained model and make it much more specific, in the medical world, for example, you've got very specific tuning you want to do that helps answer medical questions. That's where this next level comes in. From there, you have generative AI capability. So I wanted to make the point here about pre-trained versus tuning. ChatGPT, and I keep referencing that because this is the largest and most popular LLM, is pre-trained. Now you can tune that data, but what you're actually looking at is a pre-trained transformer, which is ChatGPT. So just to make that separation slightly. Okay, now this whole notion of learning, how does generative AI learn? What I just described there, that journey into learning, how does it actually work? I'm going to give you an analogy, but before I do that, let's kind of walk you through the process. So in the case of LLMs, they are trying to predict the next word in a sentence. So there's the prediction piece. Now what happens next, and if you didn't see my last video, go and watch my last video. We kind of talk a little bit about error calculation and backpropagation, but what happens is the supervising algorithm actually looks at the prediction made by the model and says, you know, these are the errors, let's correct things so you don't make that error again. And it's this repetitive process of doing that. What the model then does from that feedback is to adjust its internal parameters, and then it goes through the process again. So weighting and bias is part of those internal parameters. Now that is complicated, what I've just described there, but let me give you a little analogy for this. So imagine somebody who's got a bow and arrow and they're aiming at a target. Think of that as kind of the model. So that young girl in that video is sort of the model. Now she's going to make a prediction about hitting the bullseye. Obviously, she's not in her head going 100% sure I'm going to hit the bullseye, but think of the analogy of she's trying to hit that bullseye, and that's kind of her prediction of doing that. Now she's got a trainer with her. The guy standing behind her is a teacher, and that's the algorithm. That's the training algorithm. So the girl fires the arrow. She misses the target. What next happens is, in this error calculation back propagation pieces, the trainer says to her, you've got to go slightly higher, slightly to the left, and basically tells her where she's gone wrong. What she then does is corrects herself through this back propagation process and adjusts her internal parameters to go, all right, I need to lift higher and go left. That's in essence what we're talking about here when it comes to this whole process of iterative learning. So she then gets the arrow again and she fires it and she misses again. She's still to the right, she's still too low, for example, and again the training algorithm comes in and says, okay, this is how you need to correct this to do it. She goes through that process of iterative learning until at some point she hits a target all the time. So that's how the training process happens at a very high level within the world of generative AI. So I hope that's a clear explanation of it. We don't nearly need to go into the details about how it works, but imagine that analogy is how these things are learning. Now there's no human involvement here in terms of this learning, or limited human involvement. The humans are actually building out the algorithm, the training algorithms, etc., and choosing the right data, and all of those things. We prepare the situation, and then what happens is it does its own learning. So it's learning internally about how it does this, and there's these two pieces which are working back and forth, which are adjusting to eventually get to that place where they hit the target. Now what happens with large language models is they are given, say, a block of text, a paragraph. So they already know the actual answer to the question. They know all of the pieces. But what they next do is they actually break it down into smaller chunks. So what they try to do in their sort of learning journey is to actually take the first two words and guess the third word, and then guess the fourth word, and so it goes through this process. It always has the answer from the training. It always has the training data, and it knows what the answer is, and it's trying to actually then get itself to a point where it's really good at accurately predicting each of the pieces of that puzzle, so it can reconstruct that paragraph on its own, essentially by guessing the next word. So why is that really important? It's really important because from that process, and again, we don't really need to understand this in a massive level of depth, but from that process, it understands grammar, it understands the structure of language, it understands context. So it's building up this body of understanding within this, and again, the complexity, the way neural networks work is how this sort of does it. It's learning language. So one of the things, again, that confused me when I first came across this, so how does predicting the next word help you have a conversation with ChatGPT? It's because by going through that journey, it actually is picking up all sorts of other things, intelligence, essentially, machine intelligence, that allows it to have a conversation with you'd have a conversation with it, and it gets context and remembers things that you said, etc. So it feels human. It feels completely human, but it isn't human at all. It's only reacting to what you're telling it to do. There's no human there, but I even find myself when I'm working with ChatGPT, I say thank you when it gives me an answer to something. It has no emotions. If you tell it it's silly, it doesn't get too bothered about that because it's a machine. But because of this learning process, and again, because it's huge amounts of data, and it's self-learning, and it's training data, and it's going through this process that we've just spoken about to produce an output, and the outputs are astounding. So that's LLMs. Let's talk about diffusion models. So diffusion models are relatively new, and the way diffusion models work is essentially taking an image, and in this picture you've got the top image, and it does forward diffusion, so it adds noise to that picture. So it makes that picture so it's sort of no longer a picture, if you like. It's added all this noise to it. But it kind of already, and again, I'm not going to use LLMs as an example because it doesn't learn exactly like an LLM. It's not like the next word thing. It's really understanding structure and patterns, etc., etc. But it goes through this. So in diffusion models, it goes through this kind of forward diffusion where it adds noise to a picture, and then it goes through reverse diffusion where it then reconstructs the picture, and that's how it's kind of doing its learning. So let's do another quick analogy. Think of it as someone who reconstructs paintings. So there's a painting of a windmill. I'm guessing a Dutch windmill up there, and to the left you can see that it's hard to even make out. Now somebody, and this is probably a painting, so somebody's gone in and physically corrected that painting. They've used the right paints, they've used the right techniques, they've gone through this journey to go from something which is hard to see, hard to discern, to actually constructing something which is the real picture. Now that journey to get there is something that somebody has to learn. You've got to learn how to do that. So you learn techniques, you learn methodologies to do that. So in essence, you're taking something which is sort of a picture and you're turning it into a picture. That's in essence how diffusion models work. They learn how to do this, and from that process of taking something which is barely discernible to something which is a real picture, they can then create actual images from things that you ask for. Create for me an image of a windmill, for example. And you saw from my earlier example how ChatGPT could generate an image of multimodal. So this is how, and again, I'm doing this at a super high level, but it's kind of a good analogy. It kind of goes through this process of learning, and once it's learned what we've got here, it can then on its own create images based on, say, text input. So incredibly clever. And you can think of music, you can think of videos. They're different ways that they're trained, but essentially it's kind of these two analogies I've provided are two ways that you're training generative AI models to actually produce new content. So okay, I didn't want to get away from this. This is sort of an odd one to throw into at this point in the deck. But I wanted to go back to neural networks and our brains. A lot of people kind of get confused. They think that, neural networks are the same as our brains. They're certainly structured the same as our brains in terms of neurons or the neuron concept and connections and this complexity. But just to give you some sort of sense of scale, our brains have 100 billion neurons, incredible number of neurons. But there's 100 trillion connections. So imagine all this massive points, all connected together. There are 100 trillion connections, and that's how our brains work, how our brains think. It's these relationships and these signals that are sent between each of these neurons that help us understand and do the magical things that we do. So how does ChatGPT look? It's got about 200 billion connections, which is pretty amazing that it's got that much. I mean, these are huge neural networks, but they're nothing on the scale of our brains, nothing on the scale of our brains. So, they can do these incredibly clever things, and people worry about them replacing us and our brains. They're a long way away from that. And as we spoke about earlier, they're still machines, they're still artificial intelligence. It's not our intelligence. So, people kind of get confused about some of this stuff and worry. We certainly don't know where things are going long term, But you know, it still means that we train these things. We tell these things what they need to do. We train them with everything. We give them the data, with the model, the output, etc. So we're the ones that create it all. Okay, the last slide, and I want this to lead into my next presentation. This is ChatGPT. So the most popular LLM transformer. So it's the most successful, the most popular. Now there's ChatGPT 3 and ChatGPT 4. Forget when ChatGPT 3 was obviously the first, about a year ago when it came out. It was the most widely adopted platform, website. I forget what people talk about it, but you know, in terms of adoption, it took off. It was incredible how many people actually jumped on it. So ChatGPT was the first one. I think it was, like I said earlier, I think it was trained to data to 2022 sometime. ChatGPT 4 has come out relatively recently, trained on a new data set. It's really been reworked, so there's a lot more data there. It's got all sorts of new things there, which ChatGPT 3 doesn't. I use ChatGPT 4 and love it. It's amazing. So yeah, it's an LLM. People get it's confused me when I first saw this, but an LLM is text. But as I mentioned, you can generate images within ChatGPT 4, and that's an integration with their image processing models. So even though you're talking to the LLM, it is integrating into what they've got on the sort of the image generation side of things. So it is multimodal in that sense. It certainly doesn't work with video. It doesn't work. I think it works with music now, but I haven't. It's not in ChatGPT 4 that I've seen anyway, but it's becoming multimodal, as a lot of these things will be over time. So it's an LLM, but it's going to be a lot more than that over time, not just text-based. And yeah, ChatGPT is multilingual. It doesn't include real-time data, which is interesting. I've been working on something we've been calling GeoChatGPT, which is focused on bringing real-time data and geospatial data. But ChatGPT doesn't work on real-time data, and it is limited to when its training data was created. Obviously, real-time data is current data feeds, but ChatGPT, I think, goes back to March 2023 is the data set that it's trained against. And then I'm going to talk more about this in the next video. I'm actually going to walk through some ChatGPT workflows. I'm going to give you an example of how I've used ChatGPT in the marketing world, actually. But there's this new GPT store that's just been released, like hot off the press, and this idea of GPTs. So we'll talk a bit more about that. And I don't know tons about it, but it feels as though it's more of a sort of a tuned model. It's where you can actually sort of create very specific GPTs to answer particular questions. If you go and look at the GPT store, all trails have got their own GPT there, which is all about, you know, I believe they're a hiking company, so or non-profit, whatever they are, but they've got this very much more focused GPT. So that's it for this second video. I hope you liked it. We will dive in a bit more in the next one, like I said, into ChatGPT. And what I'd like to do is to kind of provide some. We've in the first two videos we've actually spoken in depth about the sort of the technology, and hopefully I've given you a sort of sense about where LLMs fit, where ChatGPT fits, the notion of models, etc. So we're diving deeper into the Gen AI world. Again, I'll probably walk through how I use ChatGPT 4, a good example, an end-to-end example of the depth that one can go into with this chatbot. And then we'll also talk about some other use cases as well. So lots more to come. Well, thanks again for joining me in this wonderful journey into generative AI, spatial technology, and augmented reality. We're going to cover a lot of ground in this video series. So I hope you like what you hear. And if you do, it would really be a big help to the channel if you did hit that like button. On another note, if you want to get automatic updates on when new videos come out, feel free to subscribe to the channel and you'll get that in your inbox. Again, we're entering a really amazing time in our world with these new technologies that are converging. And I hope to demystify that in this series. So again, thanks for watching, and I look forward to joining you in the next video.